Hey guys, welcome back to my channel. Today we are solving Leetcode problem number 34. Find first and last position of element in sorted array, right? So basically what is given in this question is we have an integer array called nums and an integer target, right? So what we have to do, we have to find target, right? Their first occurrence and last occurrence in our array called nums, right? For example, their first occurrence and last occurrence, and we're going to have to return their indices of these two numbers, right? So basically the bruteful solution that comes in our mind, right, that is go through with linear search, right? So here I'm going to explain you first of all the bruteful solution is to solve this problem by linear search, right? So how we're going to solve this question by linear search is we're going to take a variable, right, that is going to be our first and last, right? I'm going to take two variables. The first is going to be first and then we have last, right? And initially I'm going to appoint them -1. Okay, both are going to be -1. Okay, so what basically I'm going to do in this question is if I'm going to update my first if and only if my first is -1, right? If my first is going to be some other number, for example 3 or 8, anything else, right? So I'm not going to update my first. I'm going to update my first only and only if my first is equals to -1, and otherwise I'm going to update my last only, right? So in this question what we are going to do, we're going to iterate this nums, right? So at that moment if my I pointer is equals to 8, right, which is equals to target, right? So what I'm going to do, I'm going to update my first or last. So yes, as I have told that I'm going to update my first only and only if my first is -1, right? So in this case right now my first is -1. So what I'm going to do, I'm going to update my first, which is going to be 3, right? And now also I'm going to update my last is also going to be 3. Now if I'm going to move my pointer, right, if I'm going to move my pointer yeah, to the next position, right? So here what we have to do, we're going to update these variable, right? So as I have told that I'm going to update my first only and only when my first is equals to -1, but right now my first is equals to 3, right? So we're not going to update our first. Okay, we're going to update our last only, that is going to be 4. And this is how we're going to get the first or last occurrence of target in nums, right? That is going to be 3 and 4. And in worst case, if we're going to iterate this whole num, so our time complexity is going to be bigger of n, right? So this is how our bruteful solution look like, right? But if I also want to show one more thing, that we have to solve this problem by log n, bigger of log n runtime complexity, right? And also this question is sorted array, right? This question is of sorted array, means we have to search something, means we have to search an element in sorted array, means what we have to do, we have to apply a binary search, right? It's going to be the first approach, I think so, right? Because whenever we're going to heard this word, we're going to saw this word like sorted array, or we have to search something inside that. So what we're going to do, we're going to apply a binary search, right? So right now what I'm going to do, applying a binary search. But if I'm going to simply applying a binary search, it will not work, right? So what we are going to do, we're going to apply the lower bound or upper bound, right? So first of all, we need to know what is upper bound or lower bound. So this case is for lower bound, right? And this case is for upper bound. So basically lower bound is the minimum index, right? Lower bound is the minimum index where nums of I is greater than equals to target, right? And upper bound is also the minimum index where nums of I is greater than target. Do you see the difference, right? Here we have greater than equals to, or here we have greater than, right? So let me explain you. For example, here if my target is 8 and if I'm going to point this number, right, so this could be my lower bound, right? This would be my lower bound. Okay, why? Because it is greater than or equals to, right? Because my nums of I, right now my nums of I is equals to target, means it is a lower bound, right? And if I'm going to point this number, so this is what, this is the upper bound, right? Because my nums of I is greater than target and it is the minimum index also. So my greater than target, so this is what, this is the upper bound. So basically what we are doing in this question is we're going to find upper bound and lower bound, right? So we know that our upper bound going to be this, right? In this case my my lower bound is this, right? And my upper bound is this. So could I have to write 3 comma 4, isn't it? 3 comma 5, isn't it? No, right? We have to return 3 comma 4, right? This is my last occurrence of target, right? In nums, right? This is going to be the last occurrence, and this is going to be the first occurrence. We don't have to include this number, right? But if we are going to apply upper bound, so we're going to get this number. So how to get this number? How to get this number? It is very simple, right? If we're going to do upper bound, that is upper bound minus 1. If I'm going to do upper bound minus 1, so I'm sure that I'm going to get this number, right? Yes. So this is how our approach is. We're going to apply the lower bound. By apply a lower bound, we're going to get the leftmost number, which is going to be our first occurrence. Okay, and if we're going to apply the upper bound, so we're going to get this number, and if we're going to subtract 1 from it, so we're going to get this, which is going to be our last occurrence, right? So this is how we have to do. This is how we have to solve. I think you know what is upper bound, right? It is clear, right? So upper bound, lower bound, and upper bound, right? So lower bound is the minimum index where nums of I is greater than equals to target, right? And also upper bound is also the minimum index where nums of I is greater than target. So let's see the example, right? Okay, let's take an example. Okay, so here we have target that is equals to 8, and we have nums of error, right? So right now I'm going to apply lower bound. Okay, so first of all I'm going to find the first occurrence of this target inside our nums. Okay, so basically what we have to do the same as we are going to do in binary search, right? We're going to take pointer that is low, and we have high, and then yeah, we're going to find mid, which is going to be, I think, 7, right? Yeah, this is going to be the mid. So now we're going to compare. We know that what is the condition of lower bound, which is nums of I is going to be greater than equals to target, right? So this is what the lower bound condition, greater than equals to target. We don't have to forget. Okay, so now let's find the lower bound or the first occurrence of target in nums. So what we're going to do, we're going to check our mid value with target value. So right now my mid value is less than my target value, right? Means what we have to do, we have to move right side, right? Because we want 8, because in lower bound it is going to be greater than equals to, right? We want 8, so we're going to have to move right side, right? So what we have to do, we're going to have to move our low pointer toward mid plus 1th place, right? And also we have to find mid value, which is going to be 8. Okay, now let's check again mid, which is going to be greater than equals to 8. Yes, my mid is equals to 8, right? But in case but we know that the lower bound is the minimum index, right? Minimum index means maybe 8 going to be present in left side with their minimum index, right? Maybe it could be present in left side, right? So what we have to do, we have to move our high pointer to left side to check whether some more 8 going to be present in left side or not, right? Because we want minimum index, right? That is why we're going to do this. And also we're going to find mid, which is going to be 8, right? And in this case where my low or high going to overlap each other, in this case we have to stop. And also we're going to see that my mid is equals to 8, which is definitely equals to target. Here we have to stop, and here we get the first occurrence of target in nums, which is going to be 3, right? So this is how applying a lower bound, and we're going to get the first occurrence, right? Now we're going to apply the upper bound for our last occurrence. Okay, so yes, we have to do the same thing, that is low, and then we're going to do a high, and then we have mid. Okay, now what is the condition of upper bound, which is greater than nums of I is going to be greater than target, right? Isn't it, right? So I just tell you. Okay, so what is the condition? That is nums of I is greater than target. So if I'm going to compare my mid value, which is 7, and target value, which is 8, so is my mid value is greater than target? No, not at all, right? So what we have to do, we're going to move left pointer to the right side. We're going to find mid, which is going to be 8, right? Now we're going to check again that 8, right? My mid value, which is 8, is going to be greater than target. No, my mid is not greater than target. So what we have to do, we're going to have to move right side, right? So I'm going to put my left pointer toward mid plus 1th place, and now I'm going to find the mid value, right? Which is going to be 10, right? So now I'm going to check the mid value, which is going to be 10. Is 10 is greater than 8, right? Yes, it is greater than 8. So is I have to write 10, or is I have to write 5? No. What we have to do, if we're going to find the upper bound, which is 5, right? So what we have to do, we have to subtract 1, right? From upper bound, we have to subtract 1. So basically we get 4, which is the last occurrence of target in nums, right? So we're going to get 4. So now here we get 3 and also we get 4 by applying upper bound minus 1. Right? So this is how we have to solve this problem. Also, we have some edge cases are also there, which I'm going to deal those edge cases here by writing code. So what I'm doing, I'm going to make two function, right? That is going to be my lower bound and my upper bound, right? I'm going to write two functions, first of all, for my lower bound and then for my upper bound, right? So yes, let's write. So yes, I'm going to take len n equals to len of nums, right? And then I'm going to take low, then we have high, which is going to be our 0 and n minus 1, right? And now we're going to apply a simple, also we're going to take a lower bound variable, right? So I'm going to take a lower bound variable. By default, I'm giving it minus 1, right? Okay. So why I'm giving minus 1? Because in case if I didn't get target inside my nums, so we're gonna get minus 1, right? So now we're gonna do binary search, that while my low is less than, okay, equals to high, okay, so we're gonna find mid this time. So mid equals to low plus high, okay, and that's going to be float division by 2. And now we're going to check if nums of mid, right, which is going to be greater than equals to, so this is what the condition for lower bound, right, target. So in this case, what we're going to do, we're going to assign lower bound lower, and then we're going to do b equals to mid, right? And also we're going to move our high pointer jgh high to left side, that's going to be mid minus 1, right? Otherwise we're going to move our low pointer, yes, and at the end we're going to write lower bound, right? So everything is same for upper bound, right? So I'm going to copy this code and I'm going to paste here, because everything is going to be same, right? And this all you need to do is to just change it. Here we have to do upper bound. I'm going to take upper and also low, and then okay, and we have to remove here, that is not equals to, only greater than, right? Strictly greater than. And okay, here we have to change this variable to upper. I'm going to take upper, and then here we have to return upper bound, right? So I'm going to change it to upper bound. Okay, so now you're going to see everything is same. Just the difference is that is true greater than, strictly greater than, here we have to write, and here it is greater than, right? Otherwise everything is same. Now we have to call these function. It's time to call these function. Okay, so I'm going to call these function. So let's call the lower bound first. So lower bound is going to be self dot lower, what's the function name is lower bound. Okay, so I'm going to do lower and then bound, right? And I'm going to pass my target in it and also nums. Okay, here you see target and nums. Okay. And if we don't get the lower bound, so do you think that we have to search for upper bound? Isn't it? No, right? If we don't get lower bound, so it is obvious that upper bound is also not going to be present in our nums, right? So why are we going to check for upper bound, right? If it is not present, so why are we going to waste our time, right? So in this case, what we're going to do, if my lower bound, okay, equals to minus 1, right? Or also we can say that if my nums of lower bound, okay, not equals to target, if it is not equals to target, then what we're going to do, we're going to return minus 1 or minus 1. Otherwise we're going to search for upper bound also, right? So let's call upper bound, which is going to be self dot upper bound and we're going to pass target. Also, we're going to pass nums. Okay, and now we're going to return inside list, right? Lower bound, comma, upper bound minus 1, right? So let's run this code. Also, I want to mention one more thing, that we have to take upper bounds to n, right? Because in case, for example, my target is 9, sorry, for example 8, right? And in place of 10, if I'm going to take 8, right? So what will be my upper bound? Upper bound is going to be n, right? So that is why I'm going to update my upper bound into n, right? And now we're going to submit this code. Here it is submitted, and we've done this question.